Hey guys, welcome back to section 13.3, part B. Remember, we're looking at a base of E in this section, and E is a number that is about equal to 2.7, depending on how many decimal places that you take it to. Okay, today we're going to look at how E is used in an interest compounding formula. So when you're talking about investing money, let's say I go open up a savings account at the bank. I take my $100 down. I open an account. I put it in. They're going to pay me interest, not very much these days, but they're going to pay me interest to keep my money in the bank because essentially they get to use it if it's sitting there for their overall banking industry. Okay, so it's kind of like getting free money. I just leave my money sitting there, don't really have to do anything with it, and then at the end of the month, I get a little bit of money each month. Okay, and yes, the world of investing is way more complex than that, but that's essentially that deal. Okay, and so, but what's the principal amount? The principal amount's the amount that you start with. Okay, so that's my little $100 that I took down to the bank to open my bank account. Okay. 13.4, we're also going to be looking at some compounding interest, and there are various ways that you can do it. So the one we're going to work with today is specifically if it's compounded continuously, and if it is compounded continuously, here is our formula. Okay, and so A is going to be the amount you have at the end of whatever time period. Okay, P is your principal amount or the initial amount you put in, right? Just like from the equation before, y equals a times b to the x power. Let's see, E again, that's a number that's about 2.7. R is going to be the interest rate, and that needs to be given as a decimal. So you may get it as a percentage, like it's going to have 3% interest or whatever, but we need to give the decimal version of that. And T is time. How long is it going to happen for? Okay, so we've got some word problems with this. Why? Because money is a real world thing. Okay, so write an equation to find out the amount an account will have that started with $5,000. So there's our principal. Interest is compounded continuously, and again, that's important because it tells us we can use this formula. I know you only have one formula today, but you're going to get another one in our next section. So it's going to be important that you keep that in mind. Your rate, if it's 3.15%, the rate we're going to plug in is 0.0315, and 10 years is our time. Okay, so again, we're going to use this formula, and I'm just plugging stuff in. So I have 5,000. Remember, I'm not plugging in anything for E because that's a number. My rate is 0.0315 times T. And since we do know the time is 10, I guess I could have just gone straight to that step, 0.0315 times 10. But then you can see. So what's on my screen right now is actually a number. If you have your graphing calculator, you can plug it in all like that, hit enter, it should give it to you. If I just use my little regular calculator, I would put in e to the 0.0315 times 10 power first. Then I would multiply that answer by 5,000. Either way, we're going to get 68,000. I'm sorry, not 68,000. $6,851.30. And I don't know why it just made that little blob. Should just be a comma. Okay, so how much interest did I earn if I put my money in this account for 10 years? Not that the question asked, which is the amount of interest earned, and interest earned is going to be the 68.5130 minus the original $5,000. Okay, so that's going to give me $1,851.30. Okay, and that tells me that part. Okay, then we're going to do a comparison. And on our little comparison here, you can't always assume that having a higher amount in an account at the end meant you earned more interest, because it depends on how much money did you start with. Okay, so the question here, which investment will give the most interest given that both accounts are compounded continuously? Okay, and so for the first one, I'm going to say 15,000 times e to the 0.045 times 6. And that's going to equal $19,649.47. Okay, for my second one, I'm going to start with $20,000. And it's at 0.0375 times 8. Again, I'm just going to plug that into my calculator. And I have $26,997.18. The question is, which gives you the most interest? And so the bright pink one, the 26,000, that's the most money, but we need to double check and make sure see if that's actually the most interest. And so when I take away the end money minus the initial, I'm going to get interest is $6,997.18. If I find out the interest here, right, most interest. If I find out the interest on the first one that we did, I do the 19,649 minus 15,000, and I'm going to get $4,649.47. So turns out the second one is the one there's more interest in that account. Okay, that's all for today. You guys are going to follow up with the worksheet. I'll have that posted. And as always, if you have questions, shoot me an email, shoot me a text on the Remind. If we need to set up a Zoom, we can. And take care. And more soon.